Am I live? Am I really live? Okay, well, welcome people. Welcome. Some things, I guess you're talking to my foot. Let us, uh-oh. Okay, whatever. Give me a break, YouTube. YouTube is not, I'm not doing anything differently. Okay, let's have a look-see at things. Let's see. Hello, Stefan. Are you hearing me? Let's see. Alright. So what we're doing today is 2-point perspective. Here's a great example. Oh, whoopsie. Alright, so as you can see, this building is at a catty corner. We're looking at it at a somewhat of a 3/4 angle. Because it's not facing us head on like things were in 1-point perspective, we have to use 2 vanishing points for each receding side. As soon as you turn it on its side, suddenly you now have 2 receding sides. We're going to look at that in a moment, but first, let's finish up the 3-step stairs we were looking at before. How's the health of the stream doing? Okay. I've got to find my own self on my YouTube now to make sure that you guys are even hearing me. What do you say? Yes. Okay. You hear me? I'm not a choppy mess. Ay. Let's see. Let me log on to my subscriptions. Let's see. Oh, look, I'm live. Great. Sounds fine to me. You guys are even hearing me? Yeah. What do you say? Everything's great. Okay, good. Okay, you hear me? I'm not choppy. Great. Alright, well, YouTube's gonna gripe, but we're gonna move on. So, let us go to our demo mode. Alright. Is that as good as it's gonna get? Great. Okay, let's finish up those 3-point stairs or those 3-step stairs we were talking about. Alright, so we started by Xing out this widest plane, right? How's the focus? We're good and focused. Maybe we could be better focused. Yeah, a little better. There we go. Alright, so 3-step stairs. Alright, so as we were saying, we X'd out the plane, which allows us to divide our plane into half and into quarters. That's easy. But how do we divide it into thirds? That's when we rely on this perfectly vertical edge, right? We can't eyeball 3/3 would look like along this axis, but we can on this, perfectly flat axis. So we can do that just in the same old method of measuring with our pencil. Make that a little smaller. 1, 2, pretty close. Maybe a little bit more. 1, 2, boop. Oh, goodness. Alright, now where'd I put my eraser? It doesn't work. We want to make sure that these 3/3 are even right off the bat. This is one of those things. Anytime you're messing with your horizontals or your verticals, you have to be precise, because any slight deviation from perfectly level, it's going to ruin your whole shape from here on out. So we marked our thirds along this axis. That's where the vanishing point comes into play. If I line up one of these third notches with the vanishing point, wherever this edge intersects with the X, that's showing me precisely where a square 1/3 the size of the side I started with, where that should be along the middle of this plane. So you see, I got these 4 locations based off of these third points here. So let's go ahead and do that again here, rather than trying to, measure out perfectly one edge to the, or one X to the other side. That's going to be easier to do with 2-point perspective. You'll see in a few. How's everybody holding up, by the way? Okay, let's do that more or less again. Now, it should be the same increments here. I tell you what, at this point, let's use our t-square to make sure that we transfer these marks over convincingly. Alright, we're just going to use our t-square to say these 2/3 here belong there. Right here. There you go. Now we do the same process of lining these third points up with the vanishing point and draw a line just straight through the box, and you see those 2 points where the line intersects the X. Alright, there we go. Now we're able to draw the zigzag shape, or the stair shape, along these points here. You see from here to there, and then up to here, and over to there, and then straight up to the top. So let's do that carefully now. The receding edges are going to be super easy to do. It's the vertical edges we have to be careful about. Now you only need this section of the first step, obviously, and you only need the middle section of the second step, and the third step is already there. It's the edge of the box itself. So see, that would be the last step up here, and we can do the same. Well, you see that already forming here. So let's connect our verticals, or connect our steps with verticals, like wheat and wheat. From this point to that point. So you see, knowing how to do the 3-step stairs is important so that you understand how to divide things into thirds. So now that I have my steps more or less plotted out here, I just have to connect the horizontal edges. So I'm moving over connecting these 2 points there and these 2 points here. And these 2 points, yeah. And these 2 points here. Okay, so we see these stairs coming together now. And then I'm just going to freehand in the rest. Don't try this at home. Them stairs now. Beautiful. Great. Now we're ready to move on. Let's see. Any questions? I can hear you. We can hear you. Good. Good. Yes. Beautiful. All right. Transitioning now to 2-point perspective. All right. Cardboard that's like that. Alright. So let's have a quick rundown of what 2-point perspective is all about. Let's begin with the horizon line. Now, in any 2-point perspective drawing, you want to get your vanishing points as far apart as possible. So we're going to put them all the way to the very edge of the page. In fact, we don't want them inside the page at all, because if my vanishing point was here and I start to draw things to the right side of it, you would see the weakness of 2-point perspective, because everything outside of the vanishing points just gets distorted and just too hard to make out. So you want to get them as far apart as possible, because these 2 points correlate to a right angle. In other words, we could call one direction north and one direction east, right? Or we could call one forward and one right and left. But these are not, this is not a 180-degree angle. These 2 points do not correlate with, say, north and south or forward and backward. Keep that in mind. This is a 90-degree axis here. So if I were drawing a building at this kind of diagonal axis, I would want to start with the edge that is closest to me, like that. And then as soon as I establish the height of this corner, then I can start to draw the walls that are receding away from us. And that would, in theory, go all the way back to the vanishing point. Same case here. But of course we don't need all of it. Let's just go through the motions on this first pair of walls. Alright, and then wherever I want to just arbitrarily decide to chop off this wall and establish the next corner, this now dictates the placement of the remaining three sides, because now this wall will recede to these vanishing points as well. Since this is the, let's just call it the side wall, let's see. All right, so now again I can decide where to chop off this wall here. We'll just say it's about that wide there. And then I can line up these new corners with my other vanishing point, and you see wherever it intersects with my one of my original receding edges, that'll show me how deep this building should be. Alright, so I find two-point perspective to be just way more useful when I'm drawing spaces. And it's never like I go through all this work of plotting out horizon lines and vanishing points and whatnot. Normally it's just an intuitive thing. I'm reaching out for imaginary vanishing points, and as long as you have the theory solid in your head, it's something you can, not fake, but intuitively do on your own. So anyway, we see now we have this this box. Now we can start to turn it into things. I don't know. Let's turn it into a freaking castle, why don't we? So we can have an extra tower here. Alright, and I'm just going to freehand this in. That's going to there. This would be going to here. Alright, let's say I want to put a pyramid shape peak to my tower. First I would have to draw the box. Alright, so once I have a box here, then I can, X out my plane to get that point, connect the four corners to it. Got a little roof to my tower. So, you see how that works. How about a nice castle of gray skull? Dungeon bridge. There we go. Whoop, that needs to go there, doesn't it? Alright, you guys get it right? No, that should be coming from here. See, I'm doing this all wrong. Yes, that's where that would be coming from. Alright. So, there's your quick rundown of it. So let's do the actual assignment. So these two assignments, the 1-point perspective 9-box problem and the 2-point perspective 9-box problem, which we're doing today, that's going to be due along with the big imaginative drawing we're going to do as, you know, the capstone of this whole linear perspective lesson. We'll talk about that on Thursday, so don't get ahead of ourselves. Let's just focus on learning what 2-point perspective is. Alright, there's no paper. Alright, let's see. Sky, can you move a little slower between the exercises? Okay, sure thing. Okay, well, we're going to go. How did you feel about the pace of the 1-point perspective 9-box problem last time? Because that took almost 2 hours. We're going to go painfully slow. I'm sorry if I went pretty fast with that, you know, quick 2-point perspective demonstration. That's just supposed to give you a little taste of what it's about without also draining my camera battery. So let's hurry up and get into the actual assignment. Remember, it begins with a horizon line right through the middle. Whoopsie. My T-square moved. Alright, and then we want our vanishing point to be right dead center of that vanishing point, or horizon line. Okay, now we begin drawing the 9 boxes. Again, we want 3 above, 3 through the middle, and 3 through the bottom. So the way we begin that, we don't have the horizontals anymore. That's what we've lost. So remember, the 3 types of edges last time was the perfect vertical, the perfect horizontal, and the receding edges. We still have the vertical, but now we've replaced our horizontal axis with another receding axis. Let's just call this the X receding axis. And then the Z receding axis. And again, that correlates to a right angle. If we have a cube, this is the classic 3D modeling representation of space, but we have our 3D space here. The up axis, that would be the Y. Our left and right axis, that's the X. And then the forward backward axis, that is the Z. So remember, that's what these 2 points correspond to, a right angle between the forward backward axis and the left right axis. Okay, so now that, since we're missing the horizontal, we can't start with squares like we did last time. This time we have to start with just the vertical edge closest to us. So let's draw a series of those. Oh, I'm such a dumbass. This is a 2-point perspective, isn't it? It sure is. Forget about the vanishing point square in the middle. My bad. Like the quick demo we just saw, we want to get these vanishing points as far apart from one another as possible. Alright, my bad. that is not where the vanishing point belongs. The vanishing point belongs here and here. So let's continue drawing our boxes, or beginning to draw our boxes. We don't want the front edge and the furthest back edge to overlap. So we don't want to put our middle edges perfectly in between these two vanishing points. We want to kind of stagger them. So okay. Now, let me show you what we're up to here. With these corners represent the closest vertical edge to us. And I'm only going to draw the full receding edge to the vanishing point for this first box because we don't want to clutter up our space. So you see, this first vertical is the closest corner to us. The intersection of these two sides that are now receding away from us. Alright, now it's time for you to make a choice, because it's completely arbitrary where we cut these receding walls off at. Just bear in mind we don't want this box in the middle to overlap that box, and same case with the boxes to the sides. But also remember, we don't want any of these vertical edges to line up perfectly. So bear that in mind. But it is entirely up to you where you decide to terminate this wall, like that. But once you do establish that, you have to keep up, you gotta maintain the same perspective. So you'll see that when we're drawing some of these edges in the back, the vanishing point that you refer to flips. So don't get too married to the vanishing points that you're tracing back towards. You just need to try them both. Obviously, if we were to decide to cut the wall off here, and then what do we do with the receding edges now? Obviously, they can't go back to this vanishing point here because, you know, the original wall is already doing that. So you simply have to change angles, change vanishing points in order to turn the corner at all. Okay, now let's do that one more time, where we decide to chop off the side of our box. Let's just do it right here. And now we refer to our vanishing point, and then you see wherever these two receding edges intersect, that becomes the furthest corner in the back. Okay. Now, if you did everything right, if your verticals were well plotted out, then that should be the proof, or the fact checking. All right, so we got a box. So you see what I mean? We don't want these two edges to line up and overlap one another. Now, let's draw those dotted lines just so we can remind ourselves which ones, because this can begin to look confusing, which side is coming, which side is going, if you don't blatantly specify it to your own eyeballs. So we can see that well enough. Let's Let's reinforce the forward facing edges. Alright, so you want to do that 8 more times. Alright, let's see. Questions? No, we're good. Alright, let's do that across the board here. So we're not going to be tracing all the way back to the vanishing point like this for every single one. But you can see how 2-point perspective can be a lot easier than 1-point perspective simply because we've eliminated the horizontals. There's no guesswork now. We get to rely on the vanishing points for our consistency. Now's the part of the show where Steve stops talking and we all work silently alongside each other. Let's just trace out these receding edges all in one fell swoop. So you can see now we're going to have to stop short in order to prevent your boxes from overlapping. So maybe it is a good idea to do the middle boxes first. So yeah, sorry about my camera dying on us last time, but at least we know class will never be 2 hours long, because that seems to be the lifespan of my battery. Alright, let's see here. So, yeah, sorry if it feels like I'm sprinting a bit here because of that battery issue, but hey, it's YouTube. The video will be recorded for posterity and you can refer back to it at your leisure. Maybe this might start to look confusing, so maybe I should complete these boxes as I go, just for demonstration purposes. Alright. Where's this corner? About there. Let's see. So that's going to be a dotted line. Whoopsie. Shut up, Pewda. back corner. Right there. See that? Right there. Alright. Alright. There's one box. There's two boxes. If you feel you need to clean up as you go, I would highly advise it. Again, the less clutter the better. The easier this is going to be for you. Okay. Shut up, Pewda. Why you whining? Alright. So far so good, no questions. Alright, moving on. Okay. Move right along, bump, the fancy free. I'm ready for the big time. Is it ready for me? Move right along. Though, again, wherever you determine this first back edge to be will dictate where this corner ends up, and if it ends up perfectly aligned with this front corner, then that means you need to change the placement of this one. You need to bring it in or bring it out. Let's see how we do. So if the receding edges from these two corners intersect right here, that's a problem. We want it to intersect just off to one of the sides of that front corner. Ah, look at that. It did end up perfectly aligned with the forward facing corner. Great example of what not to do. See that? Yeah, so that is a problem. That's going to make drawing any shapes inside of that box problematic. Now if this were, you know, a perfectly opaque shape, you know, if we were looking at the outside walls of a structure, it wouldn't be a problem. But just for this particular assignment, we want our edges to be very distinct. So since my eraser is a punk, I should really show you guys how to fix this. But this box, I think, is a lost cause. Alright, so that means we would want to move that corner. So imagine if I were able to erase all of this back immaculately. You guys shouldn't be drawing as hard or as heavy-handed as I am with all this preparatory drafting work. I'm just doing so because you guys need to be able to see it on the intro lids. Alright, so all we have to do is just move this edge here in or out. Let's move it in. So right there. Now, let's see where that places the back edge. Good. So that places the new back corner right here. There we go. All right. So let me draw two more boxes. You guys obviously need to draw all 9. But let's move the demo along faster. If anyone is really struggling with this stuff, you can call me and I can try and coach you through it after the demo. Linear perspective is just one of those things in drawing. Some people it makes perfect sense to, others, let's see how that ends up. That might be a little dangerous. These corners might want to overlap here. Probably not, I don't know.
It's all depending on where we place these side corners. All right. Okay, good. So they're not going to overlap. Okay, that looks good. Let's make this box super deep. Oh, that's no good either. We got another. Look how this works out. You see? Well, that's too close for comfort, isn't it? Yeah, we don't want these vertical edges overlapping, but we also don't want these receding edges overlapping. So let me move that back edge. So again, you should be doing all this drafting work with your H-grade pencils very lightly. And then as the shapes develop, your marks can get darker and darker by upgrading or downgrading if you want. I don't know, I call it upgrading because I like dark pencils. What's the point of a pencil if it don't make a mark? Let's move forward right here. Beautiful. You guys can barely see that. Alright. So, let's go back to our list of shapes. Now, once upon a time I had 9 shapes. I know what the 9th is, but it's a ridiculous bitch and we're not even going to mess with it. But again, here's your 7 shapes. We have 9 boxes, so if you screw up inside of one, you don't have to do a lot of erasing to backtrack. You could just start over in an empty one of the extra 2 boxes. So let's start with the pyramid and move on to the prism, the diagonal box, the cone, the cylinder, the 3D T, and the 3-step stairs. So remember how we did the pyramid. It's just all incumbent upon Xing out this top plane to find that middle that middle point for the peak of my pyramid, because the square base of it is already established. Let's do that in the middle box. It's really up to you which one of these boxes you choose, but I find that the ones, well, really, these are pretty nice too. The middle one is just the lamest box to try and draw inside of. So that's why we're going to do the easiest shape inside of it. So again, we just X out that top plane. So that shows us where the exact middle of this receding plane is. It's right there. So there's my dots. I have my 4 corners down here I need to connect with this one point atop. Where's my marker? Where is it? Someone stole it! Damn it. Where'd it go? Oh boy. Okay. I did have it, did I not? Yeah, I drew the stairs with it. And then I casted it away. Ay. So well organized. There it is. Found it. Alright. Alright. So we want to darken up the base of our pyramid. So through this assignment, whoops, that's supposed to be a dotted line. Let's connect these guys first. Through this assignment, you should be able to roughly figure out how to build any kind of structure you want in your drawings. This covers pretty much every basic geometric object except for a sphere. And of course, in 2 dimensions, a sphere just looks like a circle, but what fills out the volume of a sphere is not the edges, it's the terminator. So we're going to have to learn where our light is coming from and how to show that in these fictional spaces, but the main thing that makes a sphere look like a sphere is the fact that it has a shadow plane side and a light plane side, and that terminator makes a certain crescent shape because of its round volume. We're going to talk about the perspective of light next time. I'll have handouts posted on that, and we'll just go over all that on Thursday. It'll be a lab day, a time for you guys to work not just on these, but also start on your first assignment or your final perspective assignment. I'm still trying to figure out how to format that, considering we're not in person here. That's going to be tricky because we don't all have printers, do we? I know I don't have one. Gotta give that a little bit of thought. Alright, there we go. There's a pyramid. Let's do a prism now. Let's do that right here. Now, which side you choose to put the triangle shapes on is completely up to you, but it has to be on one of these sides. I mean, I guess you could draw a prism that's orientated up and down, whatever. In these 2-point perspective drawings, all the edges are receding, so they're all fair game. So we need to X out plane in order to get our top cardinal direction. Now this is where 2-point perspective becomes easier than 1-point perspective. We only have to do this to one side of our box. So we draw a vertical line straight through the middle of the X, in order to show us where the middle of this receding edge should be, and now we can connect the corners of my box to that point there to create the first triangle of our prism. Alright, now the reason 2-point perspective is easier than 1-point perspective is because we can rely on the vanishing points twice as much. So wherever this receding edge from this peak intersects this back edge here, at that point there, that becomes the reverse counterpoint of this peak here. And now we can just, see, connect the corners of our box to that peak. And there we have it. It's a prism. Boop, 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 boop. Boop, 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 boop. Alright, prism. Alright, moving on to the diagonal box, similar to the prism, but now we're tracing out all 4 cardinal directions. Let's do that right here. Maybe right here. Doesn't really matter, but... Alright, so again, begin by Xing out 2 opposite planes. What happened to my ruler? Where'd you go? So we're gonna, there it is. Now, alright, let's X out this plane here. Okay, now again, we just need to do that to one side in this case. Now, remember, in 2-point perspective, it's the verticals that are the wild card variable that can throw off your whole system. So we have to be extremely careful to draw very consistent verticals. I'm doing that by using a T-square here. If you don't have a T-square, that just means you need to measure the same exact distance from the side of the page here at the top and at the bottom. You gotta be meticulous with those verticals. Everything else that recedes to a vanishing point is just super easy and convenient to keep all of those consistent because you have a blatantly plotted out point that they're all radiating from. So now I got my 4 cardinal directions. Again, I just connect those. But before I do that, I can find these 4 cardinal directions or points on this back edge without having to X out the plane, just by following those cardinal points back to the vanishing point, and wherever they intersect this edge here, that becomes the mirror image counterpoint to that cardinal point. Do that 2 more times. So I'm just going to draw the part of the notch. Ooh, that's kind of tricky. See, these 2 edges are going to overlap. Whoopsie. We're pretty far into it to restart this whole shape. Yeah. Oh well. Let's draw the diamond shape by connecting each of these cardinal points. Good, they didn't overlap. Now, just connect those cardinal points on the reverse side, starting with the ones that you know should be opaque or visible edges. And drawing these reverse overlapped edges with dotted lines. Ta-da! No questions? We're good. Gravy. Alright, now the cone. Let's do that in this weird skinny box here. Just X out that top plane. You guys get the theme here. X out the plane. Alright, now we have to gesture out that ellipse, and again it's kind of like the diamond shape we did. We got to establish our 4 cardinal points. So let's X out the bottom plane too. Alright, now let's find our cardinal points using the middle of that X and the vanishing point. In this case, I'm just going to draw the section of those receding edges that intersects my box. Now with the cylinder, it will be useful to draw the entire cross section here. So again, this is where we have to freehand in these semicircles that just kiss the very middle of this edge, and we want to make sure we fill in the corners naturally. Oh man, that's gross. Look up the last demo on 1 point perspective to get all the pointers on these, drawing these ellipses. But again, remember you want to avoid flat tires, meaning they're hugging the side of the box too much. You also want to avoid diamond-shaped ellipses, meaning they're cutting too quickly to these cardinal points. Okay, and then let's connect the extreme edges of our ellipse with the middle point atop. Yeah, and we got a little cone. There. Now let's do our cylinder up here. So again, we want to completely X out our planes and then completely draw out the cardinal edges on both the top and the bottom. Alright, let's do our plus shape over the middle of this X. Oopsie, I missed. Okay, now let's start with the ellipse at the top because we're dealing with a much wider plane up there. It's going to make our job a lot easier. Yeah, you see how much easier that is? So again, you want to try and imagine these little arrowheads in the side here, and you want to try and match the surface area of each of those. Oh, can't answer my phone right now. Okay. All right. Now we can use these intersecting points on the X. I guess we really didn't need the whole plus, but oh well. We can use these intersecting points to help us trace out the ellipse at the bottom. That'll make our job a little bit easier in this more narrow plane. So if we connect, if we line up this intersecting point on the X with this part of the X down here, you see we can just project those intersecting points to the reflection of the X. Kind of like right there. Right there. Okay, that'll make it easier for us to just connect the dots. Connect the dots, la 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 la. Connect the dots, la 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 la. All right. Let us. Where's my friggin' marker? Keeps hiding. There you are. All right. So now we can trace out. All right. So since that one is on the bottom of this box, which we're looking up at, we know this is going to be the ellipse we can see the entirety of. By the way, this is a great time to reinforce the point that you see how ellipses get more and more narrow as they recede closer to the horizon, and this is exactly why, because of linear perspective. Oh, God. Sloppy, sloppy, sloppy. Dotted line, fast style, there we go. Close enough. Alright, 2 more shapes left to go. The 3D T. Remember that Again, that can be on the forward or the more forward-facing side, or on the side. I'm going to do it on the side. In fact, let's do it on the more open part. Let's X out that plane, because again, we can use our vanishing points to project the T shape over to the opposite side just by using that X again. So we only have to do all of this work once. So put your faith in the vanishing point and let it do all of the leg work for you. Alright, so now we want to do the cardinal directions here. Be careful with your vertical, but the receding edge should be easy. Just line it up with the vanishing point here. Alright, so now we have these 4 smaller boxes, or smaller squares, which we then can X out each of those. Again, it incidentally makes the diamond shape we made earlier. But it also gives us these quarter points. So it gives us this box in the middle that's, I don't know, is that a quarter the size of the big box? Or do I not know how? Well, it's the same surface area as one of these smaller boxes. Alright, so then we can use our vanishing point to trace out the armpits and the arms of the T. Like so. That would be the vertical bar. Let's not jump the gun though. Let's project all these to this side, because that's the opaque forward-facing side, which needs all of the solid lines. So, lining up this vanishing point. Oh, whoopsie. You know, in this case, it would just be easier and more precise just to do all this work over again. Okay, and then we would X out each of these smaller planes. What was that? Wow, that's just a cat. Okay, so again, let's just jump to our marker here. We're lining up these quarter points here with the vanishing point, because the armpits of our T is going to be stretching out from them. You can see where the edge of the box would create the upper edges of the T, and a perfect vertical should line up these quarter points here. So that's where we're headed, with the vertical straight down through those points to the bottom of the box there. And there's your T shape. Then I'm just going to freehand this in real fast for you. That would require the vanishing point here. And then this would come down like so. And that would come across
to the vanishing point like so. Alright. Okay, more or less. See how that works? Like magic. Renaissance magic. Alright, 3 steps stairs and then we're done. Okay, so you remember we gotta establish that zigzag shape. So we gotta set up a tic-tac-toe board on my receding sides. It's just me or does this box look wonky? Oh, maybe it's just my perspective. Alright, so let's X out the plane. Alright, again we want to divide this vertical edge into thirds. Let's feel that out. 1, 2, not quite. 1, 2, okay. 1, 2, good, close enough. Dot and dot. So there are my third points there. Alright, now let's follow those to the vanishing point. And again, wherever these receding lines intersect my X, right there, that's showing me where the intersections of my tic-tac-toe board should be. Bleat and bleat. There you go. Now you can imagine these verticals intersecting through here, and these verticals intersecting through here. See, my box was wonky. See, it's only going to be as good as the verticals you started off with. Which vertical is off here then? I don't know. That's a toughie. Oh well. Let's move it in then just a bit. Like so. Alright. I think this is the circumstance where I can project my points without having to do all that eyeball measuring of thirds over again. The less eyeballing you do, the better in these linear perspective drawings. Alright, so again I can take these points. Let's just go ahead and trace out the stair pattern so we're all on the same page. Whoopsie. Alright, so then as we draw the long edges of our steps, we can use those long edges to project out the stair pattern on the opposite side. For instance, wherever this line intersects the X right here, that becomes the new crux of my first stair on the opposite side. So that's going to be right about here. see? Now we're just connecting the dots again. Sloppy, sloppy, sloppy stuff there, Steve. Okay, and there's some stairs. Again, you see me freehanding a lot of this. That's just for expediency and beating the death of my battery. Any questions? If not, that's the lesson for today. Good luck on these. Email me or text if you have any questions or if you're really having a hard time. That's a good exception to give me a call and I can talk you through it. So have these done for next time so we're all on the same page when we're talking about the imaginary space we're going to develop using linear perspective. So have fun. See you guys on Thursday.